Yeah, Avi. Thanks.
The company from Peter Thiel. The ones that do surveillance, mass surveillance, Palantir. I would send it to Palantir. That's good. What do you feel at the moment? Yeah, emotionally.
Oh, pretty good. I mean, I'm glad that this is actually
Hey.
happening and working and like, yeah, first.
Artur, nice to meet you.
Yeah.
Take a picture.
Oh, I'm so sorry. I still haven't responded. Now we will finally have the time to discuss. Yeah, awesome. Okay, let's get started then. All good with the camera? Okay, cool. Okay. Everybody ready? Yeah, okay.
No, this is just a technical section. I want to learn more about it.
No, you can stay, come on. That's cool, I'm just messing with you. Cool. Okay.
I'm okay here.
Yes, it's great.
Not showing.
No, it's fine. We would have been told. Okay, welcome everybody. Thank you for coming. My name is Artur, and I'm a software engineer in Ceramic. Recently working on a lot of the stuff that I will be sharing today. And basically the goal, it's going to be a bit more of a presentation and Q&A, hopefully, rather than workshop. And the goal is to show you a sneak peek preview of some of the big functionalities that we plan to start rolling out in the coming weeks. The goal of all of these functionalities is basically to really enable much more robust and richer data structures and a better development experience when it comes to querying this data, updating permissions, and so on and so forth. So I was thinking that a reasonable way to structure this would be to first spend a few minutes introducing some of the new concepts that we will be rolling out in Ceramic, just to give you a little bit of a starting point. And then we will not dive too deep into this actually, but because next I think it will make sense to try and show you on examples a little bit of how these concepts are going to work and what's going to be possible with them, if that makes sense. And then hopefully we should have also at least 10 or 15 minutes for a Q&A. As you can see on the screen, the name of the new set of functionalities is ComposeDB. And the central notion, the central new idea behind ComposeDB are composites. You can think about composites in a way as a database schema for your Web3 app almost. Basically what a composite is a list of models that your app is going to use. So, some posts, comments, profiles, and stuff like that. And ultimately the goal is for these composites to be shareable, mergeable, to really enable composability of rich data structures on Ceramic, hence the name. And this is really that's the biggest change we're introducing. We're going to be, and also a disclaimer, everything I'm sharing right now, it's kind of publicly available on GitHub, but not really. And we haven't even finished any robust testing stages, so it's really just a hacking opportunity. Actually, one of the bounties that we sponsor is about finding bugs in the library that I will be presenting to you right now.
You're wondering how fresh is it? What is a bug bounty as a second? So if you do it and it doesn't work super well, at least you get the bug bounty. So it's a win-win either way.
And by the way, meet Avi, our product manager.
Just running around sweatily and trying to get people in this room.
Yeah, thanks, man. So.
Or do you want to before you go around, if you did intros, maybe we want to hear from some to folks? Or actually, we'll do it after.
No, let's do this. That's a great idea,
I feel
actually.
like for the live stream, not great, but for this room, honestly,
Yeah.
I don't know how many people live streamers do, but I'd love to hear what you guys are working on, and
Yeah.
maybe we can tailor that to it if that makes sense.
Yeah, absolutely. So anybody wants to start, like say a few words, what's interesting for you?
And it's cool if you're just like trying to decide, and it's like the first day, but I'd love to hear what you're working on.
So my hackathon project is Port Protocol. It's porting Web 2 content into Web 3. So whether that's images or videos or stock photos or music, just sort of like doing the creative attribution that comes with having stuff on chain. So Ceramic could be cool to just throw all kinds of different data types at.
Do you have already any experience with Ceramic? Or are you like, super fresh and you're just looking for some guidelines?
But
cool.
Ceramic might work better.
Very cool.
Awesome. Sounds good. Anybody wants to go next?
I joined a team around the project about reputation and identity. I mean, collecting reputation of people in a market, in a labor market. I mean, I don't exactly know what we are aiming. I mean, it's not my project. I just met the person 2 days ago. It's just interesting and cool people. And but yesterday I met, I think, someone from Ceramic at DSI.
Joel,
Yeah.
Joe, he was a blonde guy.
Swedish guy.
That's our CTO, yeah.
I don't know what he is for Ceramic.
CTO.
Oh, this is
Yeah, co-founder and CTO, yes.
Yeah.
Also chief Swedish officer.
And yeah, he explained a little bit what it was, but it was not very clear, and I'm curious about it.
Okay, sounds good. Anybody else wants to share?
I haven't chosen yet my subject for the hackathon. I'm just trying to learn a little bit about the subject because I work as an ML engineer here in France at the railroad company. So we use all sort of data, non-tabular data as well. And I was kind of getting a sense of how Ceramic could replace somehow MongoDB, for instance.
Got it.
So yeah, just learning for the moment.
That's great.
One of our lead engineers used to work on MongoDB, so you're right. It's not exactly like NoSQL, but we're very unstructured with the data and kind of get into it in the question round, but it is adjacent.
Yeah, but that's a great call. Like we have Spencer, one of our senior protocol engineers who has spent 8 years in MongoDB, so he will be able to answer everything about how it compares and give you any recommendations you might need. Awesome. Who wants to go next?
I'm Eliam. I work for the Graph, and I just found this topic super interesting, so I wanted to listen in and learn something.
Okay.
We love the Graph, and also it's a small fact, and you can take it back. I went to college with Kagan way back when, so the guys' engineering team is very awesome, and one of the best. So we love your feedback. So.
And we were just talking literally 5 minutes ago about how interconnected the community is and how you meet a lot of people. Like that's amazing. Awesome.
Hi, my name is Hide. I come from Tokyo. I have 2 projects on Ceramic. So one project for this hackathon, the Web3 Patreon. We are using also Orbis SDK. And just another project for previously hackathons that is like on-chain business card, decentralized link or something like this. I'm interested. I think I like Ceramic because it's more useful for users, more easy to use it, and it's more like decentralized, and it's more user friendly. That's why I'm interested. But I'm not core engineer. That's why I didn't understand much yet. So I'm interested in what's the differences between ROV and Ceramic, the IPFS, and the blockchains. So it's kind of similar concept but different. I'm still researching, but and I'm not understanding yet between Orbis SDK and Ceramic itself, something like that. I want to discuss about that.
Awesome. And we almost met in Barcelona 2 weeks ago, but we were missing each other constantly, and finally we can spend some time together.
So I know you probably shared a little bit in the beginning, but I'll also share just a little bit more context. I feel like it will answer some questions. So Ceramic's been around for about 4 years, and so in different iterations, but it really started as like an identity thing. And so how do we allow people to potentially link their Web 2 accounts to Web 3? How do we build these primitives like reputation around it? But what we realize is like that's kind of like a community effort. And so over the last 4 years, now there's like a working group that's been, maybe you've seen Sign with Ethereum, it's called like Casa, Wallet Connect, a bunch of different protocols all joined together and kind of create this umbrella group for like identity and sign-in. So there's still some work to be done, but we've moved away from identity to basically like the simplest thing is the app database. And that's really like the biggest pivot, and you're getting like a very raw, like finished 2 weeks ago cut. But the vision of it is
The last PR was merged, I think, literally 2 days ago.
But what's fun is like, I will say, I normally don't mention it, but like we raised 30 mil, we have like a really awesome team, and so like this is the first kind of, I think, something really powerful, and this is like the first true like decentralized DB, and where it kind of fits in the stack is IPFS, and if you use BitTorrent as a kid, I did, like it's really, that's about peer-to-peer, and it's like pub sub and subscriptions, and that's IPFS is a really powerful system for file sharing. But if you use it, you know, like the content address changes every time you update the file. And so Ceramic is kind of this mutable layer on top of it that keeps data available for your app. And so this new shift that we're seeing, and where we think this is going, and Orbis' example of it is, you have a bunch of people creating apps that are around using, you know, sharing NFTs as part of social media. NFTs are really just a media file, and so people are creating social apps to discover it. And there's new things around DAOs, and so like people are creating tools to like talk to other folks in your DAOs. And so all those kinds of apps that are built on DAOs and NFTs, that's what Ceramic really serves. And so that's really kind of where we fit in. So on top of IPFS, and the layer above is like Orbis is creating an SDK, so you can, if you want to do social apps on top of Ceramic's kind of mutable data layer, that's really how it all fits in. And so if you're building like, reputations, these are all really awesome use cases, but you're gonna kind of drink from the fire hose and hopefully that context is helpful.
Awesome, thank you so much, man. And also, by the way, please meet Giovanni, our smart contracts engineer.
On the protocol side, helping on the team. Amazing team if you guys don't know everybody.
Yeah, also we joined on the same day, so we're together.
There's like 6 of us outside who also want to help you, but we don't want to cut through.
Absolutely. Thank you so much. So like all that Avi has said, and I think that's amazing product context. So basically, our mission is to provide like data, like structured to data stored on peer-to-peer, like mutable data, sovereign, composable, and so on. And we believe that ComposeDB is going to be a significant step in that direction. Over the last couple of months, we have worked on this concept of the composite that I already mentioned. So the idea is basically, it's like I said, give you a set of tools that will make it easy for you to define using familiar structures and tools like GraphQL, for example, define a set of models that your app was going to use, and then generate all of the infrastructure and helper files that we will then use to create GraphQL schemas, indexing on the node, and then provide, like, make sure that that whole development experience is where it should be, and also retain, the qualities of Web3, like, portability, composability, and so on and so forth. So composites really, like I mentioned, like the central new notion behind the whole ComposeDB iteration, and like a couple of additional things I already mentioned, like GraphQL and indexing are big new kind of like highlight words in ComposeDB. Like GraphQL, we will basically generate the schemas mutation based on the GraphQL schema definition language-based definitions of your composites, so that you can interact with your data layer using familiar tools. And then indexing provided on the node using either additional database, either Postgres or SQLite, to make sure that everything works as quickly as possible, So we also figured out how to configure the node properly so that it knows which data to index, how to update the index based on the PubSub side of things from peer-to-peer networks, and as well as like our HTTP clients and so on and so forth. And last but not least, actually something that has been already available for a bit with our current IDX protocol. So sign in with Ethereum and Kakao, but I think it's still worthwhile to mention because generally this is like the top layer that will allow us really, or actually you, to provide like really nice, smooth user experience. So signing with Ethereum, I'm sure you know, but just like a quick recap, a standard that basically uses JSON RPC to allow Web3 app developers to kind of customize the messages that people need to sign when they log in with Ethereum. So now with signing with Ethereum, instead of a strange mumbo-jumbo hash, you can have something like, hey, your DAO app wants you to give them permission to modify your tasks, and so on and so forth. And also it is time-bounded, which is configurable. So you can give permissions for an hour, a day, and so on to particular resources that your app uses. And what it enables is that basically your users don't have to sign in a message every time they want to update something. They just have to do it once, and then we take care of, all of the permission layer, and we make sure that, if the permission had been granted for an hour, then your app for an hour can update the resources and so on and so forth. And Kakao is the last kind of like cherry on the top. The name comes from capability-based access control, and basically what it does is that, you define resources when you use sign-in with Ethereum, and then Kakao you define capabilities to modify particular resources, and this is the format to describe these resources.
I'd say the summary for the end user, though, is probably the simplest, most familiar experience comparable to Web 2. And I'll be honest, like Web 2 UX beats Web 3. It's a hot take, but it's hard to balance privacy with UX. And so now, basically, like for an user, they sign with their wallet on an app, and just will always say sign with Ethereum. They click, they authorize the wallet, and then like Arthur mentioned, like for the certain kind of objects, the model, the composites, we're saying, hey, like we're going to edit your profile, we're going to read access this one. It just says, here's the 3 things we're touching. And they say, yes, okay. And for that time-bound period of time, like a session in Web 2, honestly, we can do it. But however, like there's we'll share after lots of math and how that makes sure that the user controls and has access all throughout that period of time. And they could always move that to another app. The user always has control, but it creates, in that moment when they sign in, Web 2 basically familiar kind of sessions. There's more that you can do. There's async editing, like you do your own kind of Dropbox on the side. There's a lot of new things this opens. Like right now with the Web 3 app, you just sign in and then you can only edit stuff while you sign in. So this does a lot of cool stuff where the user basically delegates access to you. So it's like a nice off pair with ComposeDB.
Absolutely. Okay, so we have 15 minutes left, and originally the plan was actually to first, I wanted to show you a quick glimpse at the repo actually, so the new mono repo JS ComposeDB. So the internet is not working for me at all, unfortunately, and I don't have an internet connection, so I'm gonna be waving my hands here a little bit. But just to kind of like, I wanted to start with like showing a simple snippet of like a GraphQL mutation within our example app. One of our example apps, we have 2 example apps, one based on Next.js and one based on Webpack in the new repository. And basically, these apps are like easy node creation tools. You can clone the repository right now, install, run, see it for yourself. And basically, all of the stuff that me and Avi have been talking is like ultimately the goal is this really. You write a familiar GraphQL mutation in your app, and basically what happens is that you create data on Ceramic that is composable, portable, available, and so on and so forth. And we are launching the first step towards that. There are still some limitations at this point that I will mention. But yeah, we believe that this is like the right place to be in and the right way to go, and it should be hopefully very useful. But we of course want as much feedback from you and as many questions as possible. And having said that, now the hand waving part starts. You can see here like a video from the rehearsal actually, because and you can see my friend Matt there on the timeline on the bottom, on the top right. So basically, I wanted to show you a set of CLI commands that enable this final result for your app to be able to use all the GraphQL infra. But all of these commands, as you can imagine, require internet actually. So I will play the video.
Mobile hotspot if you need it.
Actually, you know what? That's actually a great idea. I haven't thought about this. Yeah.
Or your Wi-Fi.
Thanks, man. Yeah, I did not think about it at all. Thank you so much. Yeah, I will try to connect to my let's first and let's see. Okay, cool. So far so good. So live demo, everybody. Let's see what goes wrong. Yeah. So.
To put you on the spot.
No, I couldn't help. I couldn't thank you more. This is like super awkward, like playing a video of yourself doing something. This is much better. Yeah. So I have two tabs open. One, I have cloned the JS Ceramic repo, which is basically the repo where we store all of the code that you need to set up and run a Ceramic node. So basically, you're kind of backend, but really like one of the nodes in the peer-to-peer network that provide the availability of the data. But many of our customers set up their own nodes just to make sure, like, you know, they don't rely too much on, you know, latency in peer-to-peer and so on and so forth. So what I'm going to do is I'm going to run the Ceramic node locally on my machine with mostly default settings, but using like one experimental environmental flag. As you can see, Ceramic enable experimental indexing set to true. Because it's still like not officially released yet, you need to do this. Like we will probably remove this flag a couple of weeks from now when we are ready with the docs and the general release. So usually it takes just a bit of time because of the libp2p network that it's based on. So now it's like searching the web for addresses so that it can connect. And also is checking the database, setting up the default indexing database, which is by default SQLite. But you can also provide your Postgres database, which of course we recommend for your production setting. But this is really kind of like our current version of your best development mode. You run it on your local machine. Okay, you can see that libp2p is struggling to find peers to connect with. Let's give it a little bit more time. Let's see. And also, by the way, here you can see like this mostly default configuration that the node is starting with. If you're somewhat familiar with Ceramic already, then this is basically like known stuff. The only new thing here really from the node's perspective is the value for the indexing key. And in here, we have 3 parameters, basically the DB connection. So as you can see, in this case, we use SQLite, and this is a database that is created locally by default for the indexing purposes. This is so experimental that I will not even say anything about. And here, this is actually the interesting part. This is how you tell the Ceramic node which models to index. And this hard-coded value, and I'm going to kill it and try one more time because I feel like it's kind of hanging there. Yeah, and this hard-coded value here is actually our special stream ID. Basically, you give an array of stream IDs in here. If you're familiar with somewhat of how Ceramic data is, how the data protocol works, we have different types of streams. And each stream is basically like an initial Genesis commit and then a set of patches, consecutive commits based on top of that. And this is how we provide mutability. We periodically get a Merkle tree of all of the commits on a given node, and we do conflict resolution between the nodes, and we put the Merkle tree on Ethereum to make sure that this is verifiable, because all of the commits have to be signed with a private key of the account, identified as DID. So that's kind of like a super shortest like description of what's going on, but to explain what stream ID is and the way we are handling things, indexing right now is that whenever you start your ceramic node, you need to let it know you need to put in the stream IDs of models that you want the node to index, basically. And this one is a special ID that belongs to the model stream itself. So it tells basically by default when I use this experimental flag, it more or less just says, hey, index all of the models that are created on this node, and this enables stuff like I was supposed to show, but I can see that I cannot connect for some reason. Maybe I can try your hotspot, but the TLDR is that right now this means that if the node gets up, I can ask it to list all of the models that are available that are created on this node. We have 7 minutes. So actually, I'm thinking that maybe, you know what, maybe I will not try to bother you. Maybe let's just stop for a second and see if there are any questions. I can tell you just like, I can show you something more. Maybe let's do it like that. So I showed you the final result as the snippet that we're kind of aiming to enable. So I also can show you where it all should start in what we call development time. So basically, this is a text file that I called if ccdapp.composite.schema. And if it looks familiar, it's because it's using mostly, it's basically a GraphQL schema definition language, definition of types, with a few custom directives that we defined. Most notably, there is a model directive that is applicable to types. And this basically indicates that when we parse, when the CLI or our internal dev tools parse a definition of a composite like this, it tells them that, okay, in this case, bounty and project, you should be creating models out of this. So this is just like a simple, I wanted to show you like an example of like what I would create if I wanted to write a dApp for the hackathon that would store hackathon projects and bounties. So I created like simple 2 models. One is called project, another is called bounty. They both have name, project has a description, and the bounty has a condition. All of these are strings. One more interesting thing is like, that is maybe not interesting, but not obvious, I imagine, is that you can see the model directive accepts 2 parameters. The description is really just like a human readable thing that is supposed to make it easier to understand what it does. But the account relation is slightly more interesting. It's an enum value. It has currently 2 possible values, and both of them you can see here. Single basically means that every ceramic account can have only 1 project instance, and list means that every ceramic account can have a list. And I'm thinking if I can find in history here actually. So what I wanted to show you on top of this was basically a few of new CLI commands that we have. So there is like one command that is called composite create, and it basically takes this file, creates the models on the attached node, and stores an encoded representation in a file that you can store in your repository, share with your other devs, and so on and so forth. And that encoded representation can also be shared between nodes to make sure that each node that has to index a given composite has all of the information about the models within this composite without needing to bother about the peer-to-peer. And then basically another command that we have is called composite compile. It takes the encoded representation and it basically expands it to include more things that are necessary for the GraphQL engine below to create the schema. And this runtime representation, I call this runtime representation, is something that you then import in your app code actually and start this GraphQL client with it, and then this is how the GraphQL client knows how to create the schema and how you can use the schema. And then the last kind of helper CLI command that I wanted to show is actually called GraphQL:schema, and this command accepts a runtime representation of a composite, and it basically gives you back the schema that is created for this. And this maybe, I'm thinking that maybe it's actually worth it to show it as okay, so here you can see basically somewhere around here on the video, I basically used the GraphQL schema command. I gave it the path to the runtime representation, and you can see part of the schema here. It creates a ceramic account that is an ID. It tells you whether it's the current viewer of the context or not, and it has a single project property, because if you remember, there's a one-to-one relation between projects and accounts, but there is one-to-many between accounts and bounties, so it also has a bounty list that is paginated, and you can basically use to fetch the data. And now we have a few more minutes for questions. So yeah, I know it was a lot, but
I know it was like a very raw early preview, so
yeah.
definitely like give us the feedback, give us the part that wasn't clear. I'm sure there was stuff, so honest feedback can help.
Yeah, so just for the order, I will say that if you have any questions, please, let's chat in a few minutes outside. We have Discord, we have a new forum, which is great.
I think we have the room after this, Tim. There's
Yeah.
a lot of talking today.
Yeah, so just to get it out of the way, but if you have any questions right now, please go on.
So I'm not familiar with ceramic. Maybe just basically it's like an IPFS but composable with like the.
So IPFS doesn't really, it provides you storage, and it provides you a way to identify, like, hey, I need this file, what's the easiest way to get this file from whom? But it doesn't really provide any structure, any ownership. So we provide access control, define how mutability works, how.
IPFS is just like the file itself, like a JPEG, like an NFT. I would definitely recommend storing an IPFS, but like the whole app on top of it, which is something's changing. Like imagine a Dropbox thing where people are editing.
Yeah.
The content address of IPFS changes. So this is so IPFS is kind of the base layer. Stream does the stream.
Yeah, we provide continuity as well, right? So.
Okay, so it's every time if something is changed, I mean, there is a recalculation of all
the stream basically.
graph. I mean
It's basically
the tree of
basically, each update is a patch, basically. Think about it as like a Git model, basically, right? So we have, every node has the current state of each stream that it follows and is interested in, and then when you want to have an update, it calculates a patch on top of the current version. It shares this patch with the peer-to-peer network, and periodically this is anchored, meaning that, a node is taking all of the commits it has locally, it creates a Merkle tree, and it posts it on Ethereum, so that other nodes, when they have some data, they can always check the anchor, the last anchor, and recalculate the signatures and see whether everything is, verifiable and the data is valid. So we provide really like structure, verifiability, composability, ownership.
Okay. So you said it's very useful for a reputation system.
Avi, you want to share? We have some of our, most prominent Git. I'm not sure if you heard about Gitcoin Passport. I think like that's the most.
So Gitcoin, like if you're like Apologies invest in it, so Gitcoin does grants for different projects in the ecosystem. So probably the biggest reputation system that's been launched happened about a month ago, and Spencer was leading it. Spencer used to work at Mongo, and basically it's a reputation that can be used for different use cases, primarily for DAOs. So here's how you contributed to this open source ecosystem. Here are some of the credentials, here's what they've done. So we've done a lot of different reputation primitives. And part of the reason we think, like the first base layer of Ceramic has been for the last couple of years is those streams, which is, here are all the changes to a file on top of IPFS. But this new thing is basically saying, how do we have data become interoperable? Like DeFi, we know how all the Legos work. This is like our attempt at saying, hey, we have a reputation composite, a reputation model. You have an app that helps people find gig workers. Someone else has a task management DAO tool, and they want to find people to do the job based on their reputation. And so if you both share the same composite, that's why I would say, like, I know this is more work than a Web2 cloud database. I know this is like totally new and experimental, but the payoff is you now have interoperability in data, which has not existed before. Like everyone has their own silo in AWS. This is now, if we share the same data block, and
It's
then also,
composability,
yeah,
I understand.
exactly. So the composites are the
And
composites.
in my group now, because they want to work on a reputation system, so we plan to use the graph, and I also don't know what the graph is at this point. And his question was, what is the difference between the graph and the...
No, my question is what is the difference between blockchain and ceramic?
Wow.
There's a lot of things.
Yeah.
There's like 3 different questions just
Yeah.
rapid fire. One thing I'll say just before we wrap up the reputation thing, like Bitcoin Passport, for example, is one.
Can I interrupt? I'm sorry, Sam. We have the camera here. Would you?
Oh,
Do you want
sure.
to kind of like, because I'm sure folks would like you see you as well. Like Spencer is.
Hi, I'm Spencer. I'm a protocol engineer on Ceramic.
Yeah.
I work with Arthur.
Yeah.
Bitcoin Passport is a anti-Sybil system, so it's like to prove that you are a unique human. And basically, one of the things that's cool about that is it's basically taking a bunch of other different identity providers and aggregating them all together. So like you can link, you have a classic Web 2 identity providers, so link your Twitter, link your Facebook, but also more like Web 3 native identity systems, link your ENS handle, link your Bright ID, your proof of humanity, and you can link all of those different systems into around a single identity on Ceramic.
Git passport.
Gitcoin passport.
Gitcoin. Sorry. Yes.
And what's cool about that is that like Gitcoin is using that internally for their application because they have grants based on where they weight the grants more heavily if more unique people have contributed to them.
For diversity, yeah.
Right. And so it's called quadratic funding. It's a way to like make sure that big whales don't totally distribute more power to sort of a more diverse contribution pool. But that's subject to this Sybil attack, it's called, where like you just sign up for 100 accounts and then it just looks like 100 people, even though it's only one person or a whole bunch of bots, right? It's like almost, you call it bot protection. But so by linking all of these, but they also don't want to just be like, just link your Facebook, right? It's like now you're tied into this one platform. The nice thing about Bitcoin Passport is that you can link all these different platforms, all these different identity systems. If a new identity system comes out tomorrow, you can add it in and you can build this like view of like, oh, the more different things you link, the more increasingly confident I become that you're a unique human. And so Gitcoin uses it for themselves, but they've also open sourced the library for how they calculate the score based on the data. And their library, it doesn't hit a centralized server. They're not making a request to Gitcoin's web server where like if Gitcoin went away tomorrow, it would stop working. The library, all it does is it reads that out of Ceramic and then just like does some calculation and verifies some of the data off of Ceramic. And so like as long as Ceramic, which is a decentralized peer-to-peer network, this is very resilient, like stays up, all that data is there, and then you can build in your own application, your own systems that also include confidence that you're dealing with a real unique human and not a bot. So that's like a really good example of this interoperability, that now all these different applications and all these different systems can all build on a shared notion of like a proof of humanity by like taking all this data from different sources. So that's like one example of a reputation system, but like that really leverages the interoperable nature of data on Ceramic. So that's my reputation pitch.
That was great.
There
And
are other questions.
there was also a question about like a little bit more general, like the way I understood, please correct me if I'm wrong, is like, what's the difference, like you mentioned, between like a blockchain and Ceramic? The way I understood it is like, is Ceramic just another kind of like blockchain technology? And if yes, then like what's different? If not, what's different? I think maybe we can tackle this in a few words, but
Ceramic itself is also blockchain. Not blockchain,
No.
but
Ceramic is not currently a blockchain. It may or may not include a blockchain as some part of its architecture in the future.
blockchain is a decentralized storage.
That is one thing that blockchain is, yes.
Right?
But blockchains are,
decentralized storage is not blockchain.
you can think of Ceramic, like,
It's more like torrent.
yeah, Ceramic
you
basically.
think of Ceramic has these like streams, these like event streams that are used to build up current state of documents and like database state. Those streams of events are kind of like little mini blockchains. Like Ceramic is almost like a platform for creating millions of, it comes down to the consensus system, right? Like blockchains have this like, Byzantine fault tolerance, like either proof of work or proof of stake based like consensus system for consensus over a global state. The problem with blockchains is that they take consensus over the entire ledger, the entire history of the entire chain, which makes them really slow, really expensive, but really useful for things like financial transactions where you need all the data sort of be part of one interconnected set. With Ceramic, we're designed for user data, and so like one user profile does not need to be able to make an atomic transaction with another user profile. Because of that, we can have consensus at a much more fine-grained level and be much, much, much more scalable. So like, we're trying to scale to, millions or billions of transactions a day, like a whole different scale than any financial chain. It's because, and we can do that because we have looser requirements than a financial chain. Ceramic will never support token transfers from one account to another account.
I see. So Ceramic, blockchain, the big difference between blockchain and Ceramic is that blockchains, always data is synced in the always, right? But Ceramic is not synced, right? It's not guaranteed it's synced.
I would say the difference is consensus over the entire network state versus consensus over smaller pieces
Where
of
are
network
the
state.
data stored?
Do you want
The data, because the IPFS,
Where is the data stored? All of the
Yeah.
data is stored on IPFS. Every commit, like Spencer said, like we mentioned, like every stream is a stream of commits, and every commit is basically a blob of data. It's like a JWS, basically blob of signed data, and it's stored on IPFS, and then what we pass in Ceramic network are basically those CIDs, commit IDs, like that are just addresses on IPFS. And it's like simplification, but
there is natural persistence because you all the time renew the
I mean,
data.
we provide basically like every stream is like connects a change. It's like Avi mentioned, like
Because in
one of
IPFS, one of the problems is there is no persistence.
exactly. If you change the content, you have a completely different hash, and there is no connection. We provide a data protocol to connect basically these hashes.
I think you're talking about like incentives for state availability, like right, like you ping your
but I know
data
that
on one
basically
node.
you may lose your data if they are not copied. I mean,
If there's not copies, right?
some
So by default, Ceramic
Oh.
writes that like every Ceramic node has a corresponding IPFS node. You can pin the data against the IPFS node. That will give you one copy of the data. If another application or another node on the network loads the same stream, pins the same stream, now you might have redundant copies. But you're right. Right now, there is no built-in incentive to ensure that many copies of the data remain across the network so that the data stays available. So that is something that we are working on.
Because if you may lose, I mean, they are all connected to each other. Since this is composable, they are nested things.
Yeah.
Well,
So,
for
So
each
if you
stream,
lose the
so like Sensor says,
one, you lose the entire chain of.
Yeah.
you lose the entire chain for that stream.
Yeah.
The other streams will be unaffected. The other data streams will be unaffected. But yes, if you lose a link in the middle of that stream's data
Then you need
will
to
be
use
broken.
something like
Yes.
FICO.
So this is why, I mean, state availability is really important for the system in the long term. So we have plans to build out a basically state availability layer over these data streams. So we're going to be using like a state availability sampling approach, kind of similar to Celestia, but not with the whole erasure coding thing. I don't know if you're familiar with that, but there will be the crypto economic. There's no token on Ceramic right now. There's no cryptoeconomic incentive.
You do have the brown.
There will be. So a big part of the reason why Ceramic eventually does need a token is to power the cryptoeconomic incentives to drive state availability, so that there will be nodes who can join the network and provide as a service to the network, storing redundant copies of the data so that streams stay available. That is absolutely a concern. The way it works now, most applications are basically running a node that supports their own application, and their application node maintains the state availability for the data that their node cares about. And there are tools in IPFS to to make backups, to have redundant copies. You can store it on S3 or create local file system snapshot. Like there are ways to make sure that you don't just have one point of failure. But it is up to each node operator, which generally is each application, to make sure that their data stays available. But eventually, longer term, they won't have to do that as much because the network will take care of state availability for them.
So do you have the plan to solve that IPS problem?
It's very similar to IPFS in that like you can run your own IPFS node and pin it yourself and keep local copies yourself. You can use a service like Pinata, where you pay someone else to keep redundant copies of your data, or you can use something like Filecoin, where you have like cryptoeconomic incentives around maintaining the availability of that data. Like it's going to look very similar to Ceramic. So you can kind of do the first thing today. The second thing would be very easy to build. Anyone could build it tomorrow, and then like the built-in native cryptoeconomics like will be coming in the future.
I see. Do you have the plan to change from IPF node to Arweave?
Arweave?
Arweave.
You can back up the data to Arweave. You can use Arweave as a backing persistence layer for IPFS to make sure that the IPFS data stays available on the Arweave chain. And so that's something like you could do. You could do that with Ceramic just as like you can do it with any IPFS-based system. We're not going to build we're not going to switch wholesale over to Arweave, but like we could easily build, or anyone could build integration with Arweave to back up the IPFS data. We already have a Filecoin integration, so you can back your IPFS data up to Filecoin. It'd be pretty easy to build one for Arweave as well.
I see.
And we would love a pull request. Wants to build that. Good hackathon project.
I'm building like two decentralized identity product, like a Web3 Patreon, Web3 LinkedIn something. So my conclusion is besides Ceramic as database, data storage is the best way to do it. Hypothesis is correct. So we have the another choices, right? I think that for Polygon or Near, or every blockchain has also alternatives to do that. But the blockchain is not best place to have the data for social. It's not mutable right now. It's not social data is kind of more like cross-chain data. But if you have Polygon, we cannot. It's difficult to see. That's why I'm deciding Ceramic. Both projects.
And Ceramic will frankly just be a lot cheaper because we don't need the same level of consensus guarantees as you need on a financial-based blockchain.
I think this hypothesis is correct. So
I mean, this is part of why we built Ceramic, right? Is that like putting social, putting profiles, putting identity information.
Do you want to pay for a link?
The scale of that, you're paying for consensus over the entire ledger, which like is important when you need to be able to atomically transfer balances between accounts. Like you can't partition that if one account. This is why like Ethereum's been working on sharding for 17,000 years, is because like it's really hard to do it in an efficient way. If like one account lives on shard A and the other account lives on shard B, you want to transfer tokens from account A to account B, like
in this age, user doesn't want to do that. Doesn't want to pay the gas fee or something.
Right. And like there might be some version. Well, it's actually not even clear. Like I don't even want to say that there's going to be like a transaction fee on Ceramic or not. The design there is still unclear. But even if there is, it will be so many orders of magnitude smaller because we don't have this problem of you need consensus over the entire ledger in order to do any transaction because every object on Ceramic is independent of every other object. Whereas like accounts on Ethereum are not independent of other accounts because they can transfer. And they need to be able to transfer and you need to be able to update both accounts atomically. It's one transaction, all or nothing. Ceramic, there's no messaging from one Ceramic document to another Ceramic document. Like these are independent documents, which means they can live on different nodes that don't talk to each other. And that lets us scale so much more.
So it's 9, I know we've kind of blown past
Yeah,
that,
sorry.
but we have like 6 engineers outside. Spencer actually the MongoDB alum, so if you have questions kind of on that, but I want to give everyone the kind of question space they need because you're all kind of going down, I would say like reputation and social probably have some overlap, but we want to give you guys any questions, and I think
we've got a whole team here.
Yeah.
It's up to you guys, but we want to bring some, if you guys want to stay here, it's up to you, but we can bring some folks in to like help, but it's up to you.
Cool, yeah, and we'll be around, we'll be around, definitely stick around for the next few minutes, answer more questions, and then we'll be around back tomorrow.
No, we
don't
don't.
have to, no. We
If-
wanted to just like open it up, bring in more of our team.
Yeah, I think it's better to
We
invite.
do smaller groups
and-
instead of,
So So what is the difference with the graph? I suppose that it has nothing